Right, let's remember that vectors are essentially movements. They're showing a movement. So if I want the vector from A to B, I want to know how I can move from A to B. But I could move along from A to D and then from D to B. So I can go along here, and that would be B. But then I'd have to go back, and that's going to be minus A. Because if I have a vector like A, then minus A is the opposite direction. Note that we tend to underline the vectors because they're made bold on the paper, but it's not easy to write that using fonts. So typically you underline them. You should do that because otherwise you can't distinguish that it is a vector as easily, especially when you start getting stuff like k times a vector. That tells me that I've got like a number multiplied by the vector. EB, okay, let's just be careful. So EA is worth 3EB. And so basically I don't want to go, oh, okay, I misread that a minute. EA is worth 3EB. So that sort of means that this is worth 3 for every 1. So actually EB is a quarter of AB. And that's going to be my answer. Okay, just be careful not to write a third because it's actually, this is worth a third of this, but overall we need to split it into 4, and I've got 1 over 4. Show that EF is a quarter of 3B minus A. So EF is over here. Right, now I can write down, this is jumping to mind as I'm doing it. EF is going to equal EB, which I have, plus BF, which I don't have at the moment. But I am told that F is the midpoint of BC. So I might just write over here that BC, because it's a parallelogram, will equal AD. Yeah, these two are the same because a parallelogram has a pair, like the sides the same length that are opposite. And so that will equal B. And therefore EF will equal my 1/4. I crammed this question up quite a little bit, so I am aware there's not a lot of room. Plus BF is going to be 1/2 B. Okay, this is all right. We just need to sort of simplify it now. So what I'm going to do is I'm going to expand my brackets. 1/4 B minus 1/4 A. I can do that just like I can do with normal expressions. Plus 1/2 B. And that's going to equal, I think I should just show an extra line of work, and it's going to equal 3/4 B, because I've done 1/4 plus 1/2, minus 1/4 A, and then I'm just going to write the answer as they've written it. I'm going to factorize out the quarter, so I'm going to get 3B minus A, and I'm done. Prove that EF and AG are parallel. Like it. This is AG. So to prove they're parallel, we basically need to show that they have a 3B minus A in it, and one's just a multiple of the other one. So let's work out what AG is and go from there. AG, I'm just gonna, can I jump straight to it? I think I can. AG is going to equal B, because I can go from A to D. But then I want to go from D to G. Now G is the midpoint, so this time I'm going to go, I'm not going to go all of AB, I'm going to go 1/2 of AB. So it's going to be 1/2 of B minus A. Alright, I'm just going to talk about very quickly again. So I want to go from A to G. I've gone from A to D, which is worth the vector B. You can see that here. And then we want to go from D to G, but D to G is 1/2 of D to C, but D to C is the same as A to B, okay, because again, because it's a parallelogram, I know what A to B is, AB rather, I shouldn't say A to B, AB, the vector, it's B minus A, so that's where that 1/2 has come from. and then I'm in a good place because I just need to sort this one out. So it's going to be b plus a half b minus a half a, and that's I'm gonna write that as 3 over 2b minus a half a, and then this time I'm going to take the half out, half 3b minus a, and that is really good because that's essentially the proof done. Why is it the proof done? Because I've basically got this vector 3b minus a, but for one of them I just go a quarter of the way along. Right, let's say this is the full vector in green. So this one here I just go half of the way along, and on the blue one I go a quarter of the way along, but you can see I'm going the same direction for both, and that's enough for them to be parallel. So we just need to sort of wrap that up. So I can write, what's best to write actually is that this is going to be, okay, I'm going to show it really thoroughly. This is going to be 2 times a quarter 3b minus a. Why have I done that? I've split a half into 2 times a quarter because now I've got this thing on the right is exactly this thing here. So AG is equal to 2EF. And that's enough. Hence, you don't need to really write anymore. Hence, EF and AG are parallel. Yeah, because I've shown one is a multiple of the other one. I suppose I've just been really careful. They are multiples of one another. I don't think this is essential. There we go. That's how you sort of prove things are parallel. Show, get the vectors and show, have the vector like the same thing, but with ideally end with something like this.